The next reaction we're going to analyze is hydration of alkenes. So remember, we have to remember Markovnikov's rule and analyze the original molecules to see how we're going to add this water into this double bonding molecule. The general reaction type is always beginning with a double bonding molecule, an alkene, which we're going to add water to. So this carbon, how many hydrogens are here? If this is double bonding to another carbon, this means there are 2 hydrogens here and 2 hydrogens here. Now, remember to only analyze the carbon atoms that are involved in the double bond. All the rest is just things that you're going to add, but for the reaction purpose, we only need to analyze the double bonding carbons. This carbon is bonding to another carbon with a double bond, so this means there's 2 hydrogen atoms. This middle carbon is bonding twice here, single here, this means there's another hydrogen atom here. Next, this carbon is bonding 3 times. There's 1 atom. This carbon is bonding twice and once over here. And finally, this carbon is bonding twice and 4 times. So this means that there's no hydrogen in this central atom. Once that we know this, we can chop our water molecule into HOH. And remember, here it's not relevant because even though it's asymmetrical, what happens? They both have the same amount of hydrogen, so it doesn't matter how we draw it. We're just going to draw H, the hydrogen, the carbon atoms with the hydroxy group that came from our original water, and the double bond is broken. Thus, we're creating an alcohol, which in this case is ethanol. So the formula type is always going to be alkene reacts with water to produce an alcohol. Let's look at the next example again, HOH. If you remember Markovnikov's rule, hydrogen is going to go to the carbon with more hydrogen in the double bond, and OH is going to go to what? To the carbon that has less hydrogen in the original double bond. So we draw the molecule again with the double bond broken, and OH is going to go to where there's less hydrogen. This means carbon number 2. So we have 2-propanol, which is 3-carbon chain, and at number 2 we have our OH group. In this molecule, again, we have the same amount of hydrogen, so it's going to be irrelevant. So when I draw my molecule, I draw my 4 carbons, and I can put it at carbon 2 or 3. It doesn't matter because it's the same carbon if the molecule rotates, and we're going to have 2-butanol as an answer. And in this final example, again, HOH, hydrogen will go to where there's more hydrogen, so this is the first atom. And then hydroxy is going to go to where there's less hydrogen. So I redraw my molecule, I draw my OH, and this example is a little bit trickier. Remember, we want to give the longest chain with the lowest number to the hydroxy group. So we're going to do 3 carbons, 1, 2, 3, 1, 2, 3. It doesn't matter, 1, 2, 3, 2, 2. We're going to get the same number. So we highlight whatever's left over, and we highlight our group. And the answer to this with UPOC naming is going to be 2-propanol. And at the number 2, we have methyl. 2-methyl, 2-propanol. So just to recap, the reaction is hydration of alkenes, and we're going to have an alkene, which we're adding water to. And after it reacts, we analyze the formula to see where we have less or more hydrogen, if that's relevant. And we attach the hydroxy group, thus creating an alcohol.